is the Waterworks Engineering Group, Team 18. I'm Jared Whitney, and I worked on designing the plans, pump station plans, and assisting with the construction estimate.
My name is Bethany Hawksworth, and I worked on the hydrology and hydraulics associated with our project.
Hi, my name is Brendan Hawk, and I created the water demand study, the water treatment plan, and the environmental benefits for our plan.
Hi, my name is Rafael Lisbona, and I worked on the water storage facilities and the pump station for our project.
I'm Mitchell Jaggers, and I worked on the construction aspects of the project and the estimate.
Del Mar Shores Park is located at 225 9th Street in Del Mar, California. The desired stormwater collection system will harvest stormwater for irrigation reuse of water targeting the grass vegetation for the baseball field and the dog park. We propose to convey a stormwater system to an underground storage area containing about 95,000 gallons of water, split up into two tanks, one at 45,000 gallons and one at 50,000 gallons. The stormwater will be treated and redistributed to the area of interest for irrigation purposes using about 420 feet of pipe. Reinforced concrete pipe. The reinforced concrete pipe will be broken up into a 50-foot pipe and a 370-foot pipe. The water will be filtered through a Storm Scepter 11,000, a Delaware sand filter, and biodynamic dry chemical feeder, storing about 95,000 gallons of water to be pumped out using a 240-volt AC Dayton pump, utilizing a 80-foot 3/4 inch PVC pipe system, moving to the existing sprinkler system. Attached above, you'll see a hydraulic grade line and an energy grade line, maximizing the 4% slope needed.
For our hydrology study, we used the County of San Diego hydrology manual to determine the peak flows into our system with a rational method. The image in the slide shows a watershed we delineated for our proposed conditions. We used empirical formulas to determine the inlet capacity and the pipe capacity for the existing pipes and the pipes that we'll be using for our project. Using the same method as before, we found the average flow entering our inlet with NOAA data to get an idea of exactly how much water that can be conveyed to our system. We found that the average flow would allow enough water to irrigate the entire park, but the main constraint was finding a reasonable storage space. As shown in these tables, our existing pipes can handle all flows, while our proposed pipe will not be able to handle the 100-year flow. The proposed 8-inch pipe will connect to the existing pipe so that any flow greater than the proposed pipe's capacity will stay in the existing pipe. The reason we're not choosing a larger pipe is to prevent the storage from overflowing. The first pipe will take the stormwater to the treatment center, and another 8-inch pipe will then convey the treated water to the storage basin. We calculated that both pipes should have a 4% slope. The existing inlet was also not up to standard, and as it cannot handle the 100-year flow. So we propose upgrading it to a larger grate inlet to allow more flow while avoiding flooding on the streets. The exhibit shows where our proposed inlets and pipes will go.
Landscaped area of the park is approximately 700,000 gallons per year. However, if we only irrigate the ball field, we would only require 350,000 gallons per year. We only irrigate the ball field in order to save on storage requirements. The water demand was calculated using the City of Del Mar Water Efficient Landscape Worksheet, which uses variables such as reference evapotranspiration, a landscape coefficient, landscape area, and the efficiency of the irrigation system. The water treatment plan consists of a hydrodynamic separator for pretreatment, a slow sand filter, and chlorine disinfection. It will be treated to disinfected tertiary standards as the recycled water will come in contact with the public. The hydrodynamic separator reduces total suspended solids by 82%, it removes floating oils and grease pollution, and it removes floating trash. You can see the plans here below. Next, we will use a slow sand filter using 0.05 millimeter filter media in order to meet the State Water Board requirements seen below. Two of these precast filters shown here will be placed side by side for the slow sand filter. Next, we will use chlorine disinfection, which will be provided by a dry chemical feeder placed after the sand filter and before the storage tanks. You can see the State Water Board requirement for pathogens shown below. You can further see the 3D model and the side cutaway view of the dry chemical feeder, and you can see how the pipes extend to the surface, allowing for the insertion of the dry chemical tablets. Next, we can see that the environmental benefits of this plan are significant, including that it reduces stormwater runoff quantity and improves stormwater quality. It qualifies for a Platinum Award from the Envision Sustainable Infrastructure Rating System. It improves the quality of life of the local community by protecting green space, and it provides climate resilience by providing independent source of water and reduces dependence on potable water.
Use a 45,000 gallon tank and a 50,000 gallon tank for our storage needs because we are only watering the baseball field rather than the entire property. And this will be sufficient for watering during the dry season. And connected to this, we'll have a pump station. So the pump station was calculated based off previously known conditions for a sprinkler system that has already been installed, and we'll be connecting our storage system to the previously existing pump or previously existing sprinkler system, and our pump has been calculated to deliver enough pressure to get water to the sprinklers with enough force to water the field.
We picked this layout because this will be the least amount of extra money that would have to be spent due to like tearing out asphalt and the ball field. So we put the two tanks up there in that corner, and then it shows you the overall like pipe layout that will have to be excavated and where the sand filter and chlorinator are going to be placed, along with the giant hole for the two storage tanks. For code, there was no specific backfill material, so I showed the couplings and I left the total number of joints up to whatever's best on the job site at no less than 1 and no greater than 4 for the larger 370-foot pipe. And then for the 50-foot pipe, we have 1 joint. And per joint, the joints are going to be rubber gaskets instead of couplings because that seemed like the better option when doing research. For the estimate, I incorporated all the materials and the labor costs for everything that could possibly happen on the project, unless a problem happens, which would consist of a change order, which happens with every project that takes place. Thanks for watching the presentation. We look forward to seeing you on December 3rd at Design Day.